Okay, welcome guys to 5.3 trigonometric graph. Let's start off with maybe recognizing the periodic property of the sine and cosine. So can anybody here tell me what that 2 pi is? Yes. Yeah, actually this is the period. So which means is that every 2 pi the value will repeat itself, right? Same thing with cosine. So this is another way of basically saying that sine and cosine has a period of 2. So when if there's a graph like this, guys, that from here to here is the same value like this, and from here to here the length is also period, in this case 2 pi. Okie dokie. Okay, so let's talk about how we would graph cosine of x. So cosine of x might be a little bit confusing, so let me change that to theta. Okay, now in the context of a unit circle, what is a sine theta? Anybody? Yes, sir.
Y value?
It is. Instead of saying y value, could we say y coordinate of a unit circle? All right, let's start, shall we? Because it's 2 pi, we're going to graph from 0 to 2 pi right here. So when you graph over here, once again, this is the x coordinate, this is the y coordinate of the theta. When the theta is 0 right here, what is my y coordinate, guys? 0, right? So when theta, this is the theta here, guys, this is the f of theta is equal to sine theta, my value will be here. At pi over 2, what is my y coordinate? Thank you, 1. What is my y coordinate at 180 degrees? Pi, 0. What is it at 3 pi over 2? Negative 1. And what is it at 2 pi? 0. Okay, so we know that's going up and down like this, but let's try to refine this picture a little bit, right? So, to do that though, let's talk about this. If it's 30 degrees, this is 1, 2, and root 3. What's cosine of 30 degrees here, guys? Yeah, it's half, isn't it? But because it's 90, we need to divide that into 3 equal parts, so that's 30 degrees right there. That right there will be half. Do you see that? And similarly, when it's 150 degrees, right? So you divide from here to here into 3 parts, and this over here is half the height right there. And you could do the same thing with negative 30 this way, right? So half, that's halfway point, and third of the distance from here to here is over here, third from here to here is here. So the picture looks a little bit better, yeah? Let's refine that even just a little bit more. When you have 45 degrees, that's 1 root 2, so this part, if it's a unit circle, becomes divided by root 2, divided by root 2, divided by root 2, is root 2 over 2, which is approximately 0.707. And as we talked about this before, at 45 degrees, it is a halfway between is 0.5, halfway between 0.5 and 1 is 0.75, but 0.707 is a little below that, so go a little bit below that right there. So that should be good enough. Let's try that one more time. Over here is half of a half makes it 0.75. It's a tiny bit below that. That's how you would estimate it. Is this making sense? Okay. How about what if it's 60 degrees, right? Then height over here would be, if that's 1 half, is root 3 over 2. And isn't that 0.866? Root 3 over 2? All right. So if it's 60 degrees right here, it's half is 0.75, another half is 0.75. The average between these two, it's about 0.866. So you could create this line. So I'm going to use that curvature to follow through because it's a mirror image left to right. Yeah? And then I'm going to copy the same kind of curvature, and that's how you draw the sine of x. And it repeats itself. Yes? Okay, good. So that's how you draw y equals sine of x, the sine of theta, and you could do the same thing with cosine of theta, where this is the x coordinate, and I'll leave that as an exercise for you guys. Example 5.3.14 in your textbook, h of x equal to absolute value of sine of x. What do you think, guys, we should do first? Yes, sir. Yeah, the graph, the sine of x without the absolute values. So let's do that first. 1, 2, 3, 4. I like to break up the sine into 4 parts simply because it looks like this, right? Has the middle, max, middle, low, and middle, right? 1, 2, 3, 4 parts. 1, 2, 3, 4. So that's what I'm doing. So that's 2 pi. And then I'm just going to do that as 1 right there, and negative 1. So I essentially have a block over here, guys, like this, right? It asks for 1 complete period, but you know what? I'm just going to do 2. Is that okay? So I'm going to go further. So from here, it goes up this way. And respect those points, guys. Okay? It looks like this. So that's 2 pi, that's negative 2 pi. But now, what do you think we should do, sir? Exactly. So here the y values are not positive, but not negative. That's important, guys. It's not negative. So anything that's negative becomes a positive like this. And let me get a maybe lighten this up a little bit. Excuse. And then we do that. And let me highlight the actual answers. So it's going to look like this. And put an arrow, and that's what that looks like. Okay, guys, could we stay focused, please? Now I have to edit this out. Obviously, that's not somebody who's troubled, but just whatever. Let it go. Well, there's a separate question, guys. Okay. The alternative to this question that you might see is maybe k of x is instead absolute values around the x, like this, right? The way that would work is that's a little bit too rough. What if it looks like this? But what happens is that anything that's negative inside behaves like a positive, right? So it creates a mirror image like this. So be careful, guys. I have students getting these two particular graphs mixed up. Yeah? Okay. Thank you. Okay, guys. We'll be doing example 5.3.34. So we have y is equal to 2 sine 2/3 x minus pi over 6. I apologize for the typo, guys. So what is the first thing I should do? Anybody? Yes, sir. Exactly. You factor out the 2/3 to the outside, right? So when you do that, this becomes 2 sine of 2/3 of x. What's here, guys? Pi over 4, right? So we have an amplitude of 2. What's my vertical shift, d? It's nothing, right? So I know that it's nothing over here. It goes up 2 and minus 2. That's all I know. And then we have period is 2 pi over 2/3, which is 3 pi. And then that is a phase shift of or you could simply write c if you like, is pi over 4. All right, so what that means is that I'm going to go 1 tick mark as pi over 4, which is here. Okay, let me take that away. All right, so this is 3 pi, which means that 12 tick marks will be the 3 pi, isn't it? So this is one period. 1, 2, 3, 4, 5, 6. That's halfway. 1, 2, 3, 4, 5, 6. I have to make one up, so that's how far it goes. And it's a sine, isn't it? So you go, that's a 6 over here. 1, 2, 3 over here. So it goes up this way, comes down. 1, 2, 3 right there. So that's what that looks like. Even though you only ask for 1 complete, I like to do a little bit more. So I go 1, 2, 3, goes down this way, right? All right. So this I know is 2. That over here is minus 2. And then that right there is 3 pi plus pi over 4. So that is 13 pi over 4. right there. Okay, and as long as you indicate the x scale and the y scale, we're good. And you want to do is put an arrow over there to show that it will continue in this particular pattern. Thank you. So we've done 5.4.40 of your textbook as an example in class. This is what we did in class. So let me do something similar just for the kicks. Okay, let's try 5.4.50, y equal to secant 3x plus pi over 2. And as soon as you see secant, you say to yourself, I'm going to graph cosine of 3x plus pi over 2, graph this first. And then, just like this over here, you would use that as a baseline. And the middle part right here, that's a 0, right? That becomes, when you reciprocate that, becomes undefined. Therefore, it becomes the vertical asymptote. And then the reciprocal of that, 1 is 1. And then it moves out this way, because that, when that value comes to 0, let's say 1/10, the reciprocal of that will be 10. If that, you get a little closer, it becomes a 100th. That height goes to 100. So you could clearly see why it makes that like a U shape. Okay. So from here to here, that period remains exactly the same. Okay. All right. So having said that, let's graph this first, right? And that means that 3 needs to be factored out. So that's cosine of 3 times x plus pi over 6. So we notice two things, this and this, right? The amplitude over here is obviously 1, and that 3 in the front, b value, tells us the period, which is 2 pi over 3, and that's a phase shift, right? The phase shift is negative pi over 6. Now you ask yourself, how many pi over 6 goes in to make 2 pi over 3? It turns out to be 4. Okay, so what I'm going to do is I'm going to use 2 tick marks right here, guys. 1, 2. That would be pi over 6. So I have 1, 2, 3, 4 of those. That distance right there, guys, is 2 pi over 3. And when we do 2 pi over 3 minus pi over 6, right there is pi over 2. Okay, so you guys do some basic math. But amplitude is 1, but I like to widen a little bit, so I'm going to take the liberty of making it 1, 2, 3. Let's go with 3. 1, 2, 3 right here. So you create this little box. Remember, this is cosine. So within that little box that you create, it starts from the high, middle, low, middle, high. So it makes this shape over here. And we're going to do the same thing over here. In that little box, I cut half, and that half I'm going to cut in half. So we got this shape right there. So you go down. You got to respect these points, guys. Okay. In the middle, after you do a while, you get the sense of the general shape. And I just like to hit the 0 here one more time. So I think that'll give me a better picture. And here as well. What I probably should have done is, instead of making it dark, I probably should have put a dotted line instead, because I'm only using this as a guide. Okay. So let's put a dotted line instead. So it'll be easier for us to deal with. Now, it might be easier for us if we use a straight edge. So this here is a 0. So when you reciprocate that value to get the secant, you're going to get a 0 right here. It's right here. And that's undefined. Okay, so that's 1, that's negative 1. And as long as you label a couple points along the y and the x, so to give us a sense of scale, I'm pretty good about it, okay? Now here is 1, the reciprocal of 1 is 1, okay? I mean, even if it's not 1, even if you stretch it out, you will touch this point. And then here is a 1/2 of the total, that's 1/3 of the way. So that's 1, it'll be 2. Half of that is 1, 2, it's right here. And 1/3 of the way is here. And then it'll create this shape right here, right? And here, 1, 2, 1/3 of the way is here, 1/3 is here. So it's going to create this shape. It only asks for one phase, I believe, one period, but I just like to do one complete picture, and then if there's an x-axis, y-axis, I like to include that as well. So here I'm eyeballing that, and that's what I have. Just to make it clear for you guys watching on YouTube, one that I highlight is in fact the graph that I am graphing. So this intermediate graph that I do of the cosine is to set us up to find the secant. I wanted to make an interesting point about example 5.466. While this is a simple calculator problem, we would draw that, and part of the graph looked like this. It would continue to go out this way, right? So from 0 to pi, we had the minimum and the maximum. And using a calculator, the answer was pretty straightforward. But the question is, why does that graph look this way? Let's do a quick examination of that. So I did a quick printout of this, guys. All right. So let us say that we have y is equal to x minus 2 sine of x. But this right here, that sine of x is between -1 to 1. So the y maximum is that the highest value that y could be is if this is -1. So that is x plus 2. And the y minimum value is when this is +1, x minus 2. Do you see what I'm talking about, guys? So let us say that we have this graph right there, right? And this right here is y is equal to x, and this is y is negative x minus 2, and y is equal to x plus 2, right? Let's think about this picture right here, guys, okay? If it's negative sine of x, the graph will look something like this. Down, up, down. See this right here? With that 4 box, right? I like to box around one period and divide the half. The first half goes down, the second half goes up, down, up, down, right? Okay, so the difference is that if we had this with 1 minus that, this will be 1, and that will be 0, and this will be 2. So it's basically negative sine x shifting up by 1. But if you have the x over here, within this value, this will go up and down. So what that means is that from 0 to 2 pi, which is here, 4 boxes, something that looks like this. It will start here, it will go up here, come down to the middle, down and up. So that's what ends up happening. And you know that at 30 degrees, which is like 1/3 of the way here, it'll go up half the distance here. And we know that, right? And then from here to here, okay. Oops, my bad. Sorry about that. That's 90 degrees, right? 30 degrees is actually here. 1/3 of the way will be half right there, okay? So it's going to start from here, it's going to go up, and the 1/3 of the way is here, and half of them is here, and it's going to hit the value like this. And then from here to here, 1/3 of the way will be the half. So it's going to hit the point like this. And from here to here, 1/3 of the way, half will be here. So that's what the graph looks like. Okay. And I just realized I drew it upside down. I just drew, guess what? Y is equal to x plus 2 sine of x, right? So I have to draw this thing upside down. So let me use a color pencil. So it's actually going down. So from here it goes down to this point, comes to this, then it comes up and comes down. So 1/3 of the way goes down negative halfway, so it does that. And 1/3 of the way, half is about here, so it does that. And that would be half of the way. And that half of the way to here, 30 degrees. So it looks like that. Okay. Yeah, so it goes up slightly beyond the 3 pi over 2. So the maximum is like over here somewhere, just a tiny bit, and I think slightly lower than here. So yeah, we can't really do this without using a calculus, but for now, we could use a calculator. But now we do know how this graph was created. Okay, so it's not a complete mystery. When you see this shape, and you can sort of see that with your calculator as well, if you typed in x and then x plus 2, then x minus 2 like this, and you can sort of see that it conforms to the same idea. And then you can see that 2 pi, I believe, is right there. So let me type in 2 pi, and it's right there, guys, right? So it goes from here, go down, and middle, down, middle, up, middle, down. So middle. So it looks just like this, right? Except this line has become y equal to x instead of y equal to 1. All right, guys, that is it for me. All right, have a good night.